Hello guys, now we can watch the ripple of my second bench power supply which I made at made my friend at the 15 years old when we was school go to school, and we have to take first of our electronics lessons, and like we start learning to electronics. So let's start measurements. Let's put some load 250 ohms on it, and let's measure the ripple. After a while this bench power supply was going so a long time, I make some improvements. I make, if you can see, here's I install the arrows current measurements and put the voltage measurements. If you can see this a self-made bench power supply, it was made at first on Germania's transistors. At that time it was the only transistor that we can get from the market. So now I remake it on the microchip LM317. So let's see the ripples on this, and I make some repairs. During this time I change the capacitors on 2000 microfarads 15 volts. So let's see what it does with the load, with the ripple. Unfortunately we can't see the current on this. It's very coarse current measurements, but when you have a much more load, you can see. Let's put much more loads. Let's put a load like 10 ohms, load, or 15 ohms load. I have some of this in my package. Special for the load in my bench power supply for the measurement. Let's put it from my bag. Let's measurement on the different load, one. Let's put the 150 ohms. What the ripples was. Let's put my probes oscilloscope, my ground probes on minus. And let's put the main probe on the plus. Oh, we have some noise. On oscilloscope. Let's put the timing. But not so much difference. Noise. What is this? What is this cursor? Let's put this cursor. It's a noise, but let's ripples. Let's measure ripples almost the same. Ripples almost the same. The frequency of ripples 227 megahertz, and the amplitude of ripples is 14.8 millivolts. So not bad. Let's change the load. Let's change the load on much bigger load, 15 ohms for example. that I have on my bench. Now. So we put the minus props on the and plus props, and we can see current. And we can see current about 200 amps. About 200 amps. 200 amps. Let's put some props on this. Let's put some props. Minus on the ground and plus on the main. On the main props. Ouch. It's difficult to catch it. I catch it. Let's see the ripples. The ripples goes much bigger. Let's put some much more voltage on this. Let's put how say 10 volts, 8 volts, 10 volts. The current is half of amperes, half amperes, 500 millivolts. The current is 500 millivolts. Let's see at the ripples. Ripples almost the same if we exclude this noise. The ripples almost the same. Let's change some timing. It doesn't change. Okay. The frequency almost the same, 220 megahertz. So the load is started to get warmer, and the heatsink is cold. It's cold now. So this is good power. This is good power supply. So I can mention that this is power supply from 1.2 volts to 18 volts. But this my power supply from 0 volts to 30 volts. So it's much improvement, and this power supply has limit at 4 amps, at current 4 amps. But this current supply has no doesn't have limitations, but it has a short protection circuit. So when you short your wired plus and minus, you can see that the amperage arrow go above the range, and current will have 2.7 amps. So it's on the protection mode. It has current 2.7 amps, but it's still good. It's simple. It's practical. I use it a lot for charging, for charging batteries, for applying voltage on my repairing stuff. So I'm very satisfied with this power supply. Thank you for the watching. Thank you for your attention. See you at the next time.